Hey everybody, it's Coach Sharf. Welcome back to my online videos. Our lesson for today is about solving quadratics, in particular using the quadratic formula to solve them. So as I'm pulling up the screen to share, it's an active board lesson, but again, y'all, it's not like when I post it on Canvas and y'all can't see it. Y'all can see it in the screen capture, so it's fine. Just takes a second to load though. So while it's loading, so again, it's just gonna be a little bit of a review of what we did with the PowerPoint about, solving by factoring and solving by looking at the graph, because those are two ways to do it. And we compared that either way we solve it is fine. And then we're also going to use then we're going to jump into using the quadratic formula to do so. There we go. All right. So again, when I'm solving quadratics, the whole idea is most of the time it's going to be set equal to 0. And I didn't put the standard form, so let me just throw the standard form up there real quick, I suppose. AX squared plus BX plus C equals 0. Again, most of the time you're going to have x squared x in a constant. Sometimes this middle term might be gone. Occasionally, you might not have C there. X squared always has to be there. So, whatever these terms are, whatever the coefficients are, I got to figure out what numbers I plug in for x, and when I do all my math, make the equation equal 0. And again, as this is switching to the next slide, let me say again, guys, I'm going to go kind of fast if you're just watching the video through. So it's not a 30-minute video, so you're going to have to, stop at each step, or, like at this screen, stop and copy it down if you need to, okay? Again, you don't really need to copy this, but there's 5 different ways to solve quadratics to figure out the x values that make it equal 0. Factoring, which we've done in class. Graphing, we've looked at a little bit. Quadratic formula, which is really what we're getting into today. And then square root method and completing the square, which is what we're doing next week. And I'll probably make a video on those as well. So again, kind of the first thing we did, let me move this screen over. Kind of the first thing we did in the PowerPoint was we looked at solving by factoring, and we looked at some graphs and compared them. So I've got this quadratic, x squared minus 2x minus 15. I didn't set it equal to 0, but that's the assumption. I did it over here when we factored. So I pulled this screen cap off of Desmos. So I typed this into Desmos. And if we look where this parabola crosses the x-axis, again, that's our solutions are where the parabola crosses the x-axis. They're shown here as the ordered pairs, -3, 0, and 5, 0. But again, what that's saying is when I plug in an x value of -3 and calculate everything, if this was set equal to y, my y value is equal to 0. So I got -3 and 5. If I factor this, my factors of 15 are 1 and 15, 3 and 5. Which of those can I use to get 2? Would be 5 and 3. So specifically, what's going to give me -2? 3 minus 5 is going to give me -2. And then also 3 times -5, again, is our -15. Since we're multiplying to get -15, one has to be positive, one has to be negative. So these are our factors. But again, my solutions aren't 3 and -5. It's got to be the opposite signs, because I'm trying to cancel out what's in this set of parentheses and what's in this set of parentheses. You can also do it by setting each of those individually equal to 0. So I set x plus 3 equal to 0, subtract 3 on both sides, which gives me x equals -3. And then x minus 5 equals 0, add 5 on both sides, gives me x equals 5. So I got -3 and 5 in the graph by factoring. And now we're going to do it with the quadratic formula to, again, show you that whatever way we could solve a quadratic to figure out whatever those x values are that we're looking for, as long as we can solve it in that method, if I do whatever math the method requires correctly, I'll get the same answer. So let's go to the next slide. Okay. I'm going to make this screen bigger now. I might have to move my video again. All right. So move the video. Move kind of right here in the middle. Okay, so I got the formula over here. Again, if you don't have it written down somewhere, write it down. You know, I'll give it to you, quiz or test time. You don't have to memorize it. You just have to know how to use it. Here's my quadratic. And again, we get A, B, and C from looking at, I'll just write it for this problem, from looking at standard form. AX squared plus BX plus C. So we're going to say A, since there's no number in front of X squared, is 1. B is -2. And C is -15. So after I identify A, B, and C, we got to write our formula. But again, instead of the letters, I like to put the parentheses, because I'm going to fill in the parentheses with the appropriate numbers that match the letters. So I got negative parentheses plus or minus the square root of parentheses squared minus 4 times parentheses all over 2 times parentheses. Okay, guys, this whole numerator has to be over the denominator. The 2 times whatever this is doesn't just go under the square root. It goes under the whole thing. So now I'm going to fill in what I got. Again, first set of parentheses is B, so I'll put -2 here. Second set of parentheses is also B, so I'll put -2 here. Third set is A. A is 1. Fourth set is C. C is -15. It's going to be a tight fit. And then on the bottom, 2A, so 2 times 1. So now, let me go back to black for a second. Again, now I'm trying to kind of simplify it, okay? So I got my plus or minus, my square root. It's really going to be 4 numbers. Again, 1 that goes here, 2 underneath the square root, and then 1 at the bottom. So the way I'm going to get those, again, I'm going to kind of block it off. I'm going to do, 4 little separate parts, okay? So the negative B on the outside, the B squared, the minus 4AC, and the 2A. So I'm going to come down here and erase these little blanks. We know there has to be 4 numbers, okay? It doesn't erase quite as easy as it does normally. Let me redraw our fraction bar. It's not going to be perfect. All right. So again, we're going to look at each of them separately. I'm going to do it in blue now. So again, all this, the negative sign on B is saying I need to take the opposite of whatever B is. So I need the opposite of -2, which is +2. -2 squared, again, when you put it in your calculator, you need to put it in parentheses. So -2 squared is 4. -4 times 1 times -15. Again, you want to make sure you include that negative when you're multiplying. So -4 times 1 is still -4 times -15. 15 times 4 is 60. A negative times a negative is positive. So that's going to give me +60 over 2 times 1, which is 2. So I've gotten my 4 numbers. Next thing to do is to try to simplify the square root as much as I can. So I'm going to start by combining what's inside. 2 plus, let me drag it down a little bit. It's going to let me drag it down. There we go. All right. So 2 plus or minus the square root, 4 plus 60 is 64 over 2. So when I'm taking my square root now, 64 is a perfect square. You all should recognize it, but there's a few things I want to point out. Going back to the vocab at the beginning of the year, I told y'all whenever we take a square root from now on, so I just gave you the square root of 64, you want to have that plus or minus 8. Because, again, the idea of the square root is what can I multiply times itself to get 64? Well, I can do +8 times +8, but I can also do -8 times -8. That will still give me +64. But the good thing about the quadratic formula is that plus minus is already built in right in front. So I've already got that down. So as far as looking at the square root itself, again, there's a bunch of options here, okay? Could be a perfect square like we have now. It could be a square root that I need to simplify. So I can't do a perfect square, but I can do my factor tree. That's actually going to be the next problem. It might be a number that I can't do a factor tree for, which is a prime number. We'll see an example of that as well. And then I could also have all those situations where my number inside is negative. We'll look at one example of that on the last problem. That's when I got to get the imaginary solutions involved, because taking that negative square root, again, we learned when I'm trying to take a negative square root, it's an imaginary number. So again, we'll see all those coming up. Let's just, keep focused on what we're doing now. So you want to take the square root next. I'll change colors as I go to the next step. Square root of 64 we know is 8. So I've got 2 plus or minus 8 over 2. So again, hopefully y'all remember this from Algebra 1. When I get to this point, what I want to do is I want to split it up, and again, I'll change colors, into 2 solutions, okay? I want to have x equals 2 plus 8 over 2, and x equals 2 minus 8 over 2. That's why I have the plus or minus, because I could do either or. So you again want to do the math in your numerator first. You want to do 2 plus 8 is 10. So x is equal to 10 over 2, which is 5. If you're really relying on a calculator, trying to put this in the calculator, remember, you need to put this in parentheses. You have to put your numerator in parentheses, or 99% of the time you're going to get the wrong answer. Over here, same thing. If you want to punch in your calculator, put it in parentheses first. But if you're just doing it by hand, 2 minus 8 is negative 6 over 2, which gives me x is equal to negative 3, which again are the same 2 answers that we got previously. All right, stretch myself out real quick. Next problem. Again, like I told you, I should have said it during that last problem, but if you need to stop after each step to copy it down, again, do that, because I don't want to sit here like you're actually taking notes in class and have an hour-long video. All right, 2x squared plus 4x minus 1. Again, that last one was a little different. Every problem from here on out were the ones that we did in class. So a is 2. Well, let me make a different color. My bad. What's going to show up on yellow? Red will show up on yellow. A is 2, B is 4, C is negative 1. Let me move my video now. I should be able to move to the corner and be all right. Okay. So again, I don't have the formula written now. You should have it off to the side. And it's just, y'all can see I already have this kind of written out for each problem going forward, just to make it a little quicker for me, so you don't have to sit here and watch me write it. But again, you're going to fill this out. Instead of negative b, negative parentheses, plus or minus square root. Instead of b squared, parentheses squared. Instead of minus 4ac, minus 4, parentheses, over 2, instead of 2a, 2 parentheses. So then you got to, again, fill in your numbers. The first 2 are always going to be b. So 4, 4. This is always ac, so 2, negative 1. And then a is always on the bottom. So again, we want to chunk it up. So I'm going to take the opposite of positive 4, which is negative 4, plus or minus the square root. 4 squared is 16. Negative 4, again, you want to include that negative if you're multiplying your calculator. Negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8. It's not the best looking 8. There we go. All over 2 times 2, which is 4. So again, I'm going to remind y'all, after we do this, we always try to simplify the square root next. People occasionally, if they don't know what they're doing, I see may want to try to jump the gun here and divide all of these by 4 since they're all divisible by 4. Again, that's incorrect. We're not going to divide till the very end of the problem if we even need to. So let's move this up here. And green's not the best at showing up, but I think it'll be okay. So -4 plus or minus the square root of 24 over +4. So again, we're looking at our square root. 24 is not a perfect square. 25, it would be 25, it would be the closest one. But you look at 24 and say, okay, I know it's even, so I know I can at least divide it by 2. So let me try to do one of those factor trees with it. Again, simplifying the radicals like we went over at the beginning of the year. And again, y'all learned this in 9th grade. So if you want to start with 2, it would be 2 times 12. Again, you don't have to. It's anything you multiply, get 24 outside of 1 to 24. So I'll start with 4 and 6. You could have done 2 and 12. You could have done 3 and 8. So I got 4 and 6. This factors to 2 and 2. This factors to 2 and 3. So cross out the ones that I factored. So this is what I'm left with. So now when I get all my prime factors, I want to pair up any like factors that I got, underline the single factors that don't have a match. Now white's really not showing up that great. So let me change the light blue as I move it over here. So you do your radical, okay? For any pairs you got, you put one number on the outside. So for this pair of 2s, I put 1 on the outside. My single 2, is going to go under. My single 3 is going to go under. Then I got to multiply those to give me 2 square root 6. So I've simplified square root of 24 into this. So -4 plus or minus 2 square root 6 over 4. And now, the last thing we always got to do when we have any kind of fraction is when I think I'm at my final answer, make sure I cannot simplify. I can simplify in this case. We don't look at the 6 because it's still under the square root sign, but if I have any number outside of it, a number over here, and this number, I got to look to see if they're all divisible by the same number. I can divide them all by 2. It's going to simplify, okay? Reduce, however you want to say it. So -4 divided by 2 is -2 plus or minus 2 divided by 2 is 1. So I'll kind of write it right here real quick. 1 times the square root of 6. But you don't have to show the 1 on the outside. So it's just going to be the square root of 6 over 4 divided by 2, which is 2. Again, you're not touching the 6, so you can't say, oh, I could divide 2, 6, and 2 by 2. Since it's under the square root sign, we don't touch it. So this is our final answer. X equals, didn't put my X over here. X equals -2 plus or minus the square root of 6 over 2. You can leave it like that. You don't have to turn the square root of 6 into whatever decimal you would get. You can leave it like that as your final answer. All right, problem 3. This is going to be the short one, the one y'all are going to say, why can't they all be like that, Coach Scharf? So, let me try to go to color skin show. I think the white shows up pretty good here. All right, x squared plus 3x minus 11. A is 1, B is 3, C is -11. Again, a problem we did in class. So -3 plus or minus the square root of b squared, so 3, minus 4ac, so 1, -11 over 2a, so 2 times 1. Again, let's chunk it up. All right. Negative, so the opposite of positive 3, excuse me. Don't let me misspeak. The opposite of positive 3 is negative 3. There we go. Plus or minus the square root. 3 squared is 9. Negative 4 times 1 times negative 11. Again, when you have that 1, you don't even really got to worry about multiplying it. So negative 4 times negative 11 is positive 44 over 2 times 1, which is 2. Change to this green now because it shows up pretty good. Okay. So now, again, I got to look at my square root. I got to add 9 and 44. Negative 3 plus or minus the square root of 53 over 2. So again, I got to look at 53. I got to say, okay, I know it's not a perfect square. Is there anything I can multiply to get 53? Well, again, if you look at your factor pair sheet, you should know. But if not, you kind of run through it in your head. You say, okay, I know it's not even, so I can't divide it by 2 or any number, even number. So 2, 4, 6, 8, whatever. I can't divide it by 3 because 3 goes into 5 one time with a 2 left over. So then I would be trying to do 23 divided by 3, which doesn't work. I can't do 5 because it doesn't end in a 5 or 0. It's not 7 because the closest thing to this I would divide by 7 would be 49. It's not 9. Again, 9 is kind of like what I was saying about the even numbers. If I can't divide it by 3, I know I can't divide it by 9. So you could try to run through everything, but you're not going to be able to divide anything into 53. 53 is a prime number. So I can't simplify this square root any. So that's your final answer. Negative 3 plus the square root of 53 over 2, negative 3 minus the square root of 53 over 2. Again, you don't have to turn this into a decimal. You don't have to say, I'll just show it on this one since there's not as much writing. You don't have to do negative 3. If we say square root of 53, let me do it in a calculator just so I don't put the wrong decimal. Then you're like, Coach Sharp, you put the wrong decimal. So square root of 53, I'm saying 7.3. 7.28. So it is 7.3. Okay. So you don't have to do negative 3 plus 7.3 divided by 2 and negative 3 minus 7.3 divided by 2. This would be what, 4.3 divided by 2. So 2.15, that would be negative 5.15 if you do all the math for that. Again, you don't have to do that. Oop. I don't know why that did that. You don't have to do that. Dang. Sorry. Don't have to do all that. You can just leave it at this. All right, last problem. X squared minus 5x plus 12. So A is 1, B is negative 5, C is 12. Fill it in. This is B, this is B, this is A, this is C, this is A. Opposite, I'm not even going to chunk it this time. Hopefully y'all can kind of pick up the pattern now. Opposite of negative 5 is positive 5. Plus or minus negative 5 squared is 25. Negative 4 times 1 times 12 is negative 48 over 2 times 1 is 2. So I am going to slide this down. Okay. No, can't do it with my hand. I don't know why it doesn't like to do it with my little pad thing. All right. So I'm doing this one. I'm sliding this one down a little bit because I need a little more room up top to show y'all some stuff. But I am going to do my math here. 25 minus 48 is negative 23. So again, I'm not going to go pull up the Desmos now. I did it in class. If you were to pull this up on a graph, your parabola would kind of be something like this, okay? Again, it doesn't cross the x-axis. So when y'all saw this in algebra 1, you said no real solutions. Okay. However, that still holds true, but we know we've learned now how to express imaginary solutions. And we have an imaginary solution whenever there is a negative square root, which is what I have here. So again, we learn how to kind of deal with it in terms of the square roots. We know that the imaginary number I, oh, thought I made that green. Imaginary number I represents the square root of -1. So anytime I have a negative square root, I'll deal with this with 23, okay? I want to separate out that negative square root of 1. This always is going to turn into I. And again, I got to deal with my positive square root now separately. If it's a perfect square, tell me what the perfect square is. If I can do a factor tree, do a factor tree. But again, in this case, 23 is a prime number. I can't do a factor tree. So it just is going to stay the square root of 23. So I have square root of 23 times I. And again, if we remember, anytime I have a square root and an I, the I is going to go in front of the square root sign. If there was a number out in front here, it would go behind that number. I'll show a couple examples like that after I finish this problem. But for this problem, I've turned the square root of -23 into I times the square root of 23. So we'll come down. So this is now 5 plus or minus I times the square root of 23 over 2. And lastly, you still have to check if you had a number out in front here. So this number, the number that would be in front of I and my denominator. Again, it's possible to simplify those. I'll try to show an example here in a second at the very end. This one I cannot simplify any further, however. So, whoops, it's not the best circle I've ever drawn. That's still not really whatever. That's a little better. These would be my answers. So these would be my solutions, and they are two imaginary solutions to x squared minus 5x plus 12, again, assuming that this is set equal to 0. All right. So that's it as far as the problems. Again, I just want to show y'all real quickly the imaginary numbers, though. One last thing. So we looked at 23. We said the square root. Oh, I didn't want that gray, but that's fine. -23 would eventually give us I square root 23. If I did 25, it'd be the square root of 25 times the square root of -1. Square root of 25 is 5 times I would be 5I. So if I had had this on the last problem, it would have been 5 plus or minus 5I over 2. And then let's say it had been 27. So square root of 27. Let's change that. It's a lot of gray. I don't want it blending in. I'm sorry. Let's change that. We'll change it to blue. So square root of 27 times the square root of -1. Again, this would still be I. Now, for 27, I can do my factor tree, 9 and 3. That goes to be 3 and 3. Move this down. All right, so that crosses out. That's crossed out. So I've got 3 3s. 2 of them are going to pair up. That one's by itself. So again, if I'm rewriting it, for this pair of 3s, one goes outside, single 3 goes inside. Still got to bring down my I. So 3 square root 3 times I is 3I square root 3. Again, this I goes in front of the square root, but behind any number I have out there. And again, if I had this on that last problem instead of 23, I would have 5 plus or minus 3i square root 3 over 2. And lastly, I'll try to make it like the second problem we did. If I had negative 4 plus or minus 2i square root 6 instead of 2 square root 6 over 4. I can still simplify the 4, 2, and the 4. I'll tell you what. Well, I'll show this one. I'll show one more. Because it's going to be one. You're going to divide them all by 2 like we did earlier. It's going to be 1i. But again, you don't have to put 1i. Just be I. So negative 2 plus or minus I square root 6 over 2. If you didn't have one that divided to be 1, so let's replace it with, I don't know, 6. So negative 4 plus or minus 6i square root 6 over 4. Again, you could divide negative 4, 6, and 4 all by 2. So negative 2 plus or minus, it's getting really tight, 3i square root, all right, now. But 3i square root 6 over 4 divided by 2 would be 2. All right. So there's using the quadratic formula to solve some quadratics. I hope that video helps. As always, if you got any questions, send me a message on Remind. Until next time, y'all take it easy.